Meow. Meow. Meow, meow. My throat hurts. Commander Mexico. Commander K. Rudd, are you autistic? Mounting Urchin 8261. Good mounting the consultant 427. And good mounting Solo Q. Do you have autism, Commander K? I'm not autistic, okay. Are you sure? Are you sure? Yeah. I'm really tired because I didn't get enough sleep. I only got like 4 hours. Manning lifetime manning aspects. I don't know. I have a lot of them. I have a lot of them in my audience. I don't even mean it as an insult. That question comes to mind whenever someone consistently, um, someone consistently says like particular things. Maybe you're a child. I don't want to ask. I don't want to know if you're a child. I don't know why you're watching this. My tummy hurts, my throat hurts, and I'm super tired. Meow, 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 meow. Also, I got out of the shower and I was in there for the reason I'm late is I was in there too long because I was laying in the bath thinking about Fibonacci numbers. I was trying to solve I was trying to solve the recursion thing. Actually, you know what? I'm gonna let me think. I want to work on that a little bit because I have some ideas. Mm, yeah. Yeah. Meow, meow. Oops, I didn't mean to do that. Oops. How do I undo that? What the heck did I press? You could just do that? Wait. I gotta try that again. What the heck did I just do? Green. S. Green. Control. E? I've been looking for a quick way to terminate this shit, but I didn't know how to do it. I'm still learning how to use this tool. Control A, Shift A is what I was looking for. We're gonna call this 0. Meow, 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 meow. Oh god. Okay, I turn on rain instead of music so I can think. Okay. So I was thinking in the shower, right? That f of 5 should be the should essentially be 25 because it's the same thing as um the it's the same thing as adding f of 4 plus 2 times 2 times f of 3 plus 3 times f of 2, which is the same thing as saying, because we already solved f of 4, f of 3, and f of 2. So this should just be 11 plus 2 times 4, which is 8, and then 3 times f of 2, which is 2, which is 6, right? And 11 plus 8 is 19, plus 6 is 25. And then if I were to rewrite these doing the same kind of thing, you could see that it's like you need the past. So like so with sorry, I'm all over the place. With Fibonacci numbers, you need the past two numbers and then you add them. So a Fibonacci number is just n minus 1, or the Fibonacci of n minus 1 plus the Fibonacci. Wait. No. It's just n minus 1 plus n minus 2. Right? Let me think about that again. No. It's not. It's not n minus 1 plus n minus 2. It's Fibonacci of n minus 1 plus the Fibonacci of n minus 2. Let me think about that more. Hmm. You only need 3 variables to do it in a loop. I'm not doing loops. We're not doing loops. We're not doing loops because I haven't learned loops yet. But thank you. I want to do it with the tools that I've been given so far because I think that's what's intended. And the other thing too is that, like, the issue is not loops or while or whatever, like whatever kind of tool that is used to do the thing. The issue that I'm having is I want to understand the logic. I want to understand how recursion is converted into iteration and vice versa, but mostly right now I'm curious about going from recursive methods to iterative methods on my own, because from the text I see how it's done, but I don't understand how it's produced. Like I find recursive processes easy to understand and easier to understand and parse. But I can't say the same about iterative processes, even though, so cuz all of this is still recursion, but yeah. Um I want to be able to go from take the product of n times the factorial of n minus 1 and be able to produce this, like, okay, I need the product, I need a counter, and I need the max count. I don't even know how this jump was made. This is just what was done in the text, right? Or this version 2 where they have it, like, they have it, what is it called, embedded, like like a procedure inside a procedure. Then you just need the product and the counter, and then it uses n. Anyway, so I understand that iteration is like counting steps, and that seems why the examples shown in the chapter use count, they use decrement and increment. Anyway, and then this one is also the count change one is also one that I don't fully understand yet, but I'll come back to that. Anyway, I should do more problems probably. Mhm. I feel like chat is trying to make me cry today, but I'm not falling for it. I'm not gonna cry. So, good luck, buddies. Let's see. And the other thing I was confused about was that I was doing f of 5 and getting something other than Other than 25. Misty, I think you need to take a break from my content. I think you're too, yeah, I think you're too tuned in. Honestly, I was thinking about your comment yesterday about me talking about my secret streams. These streams are mine, not yours. So when I said it was a secret, you know, I can joke about it because it's mine. And if it's a secret, it's my secret, so I can tell who I want. And then the fact that I was thinking about this morning, that comment bothered me again. So I'm just gonna ask you to just give me a break today, please. I'm getting yeah. I think you're spending too much time and obsessing. Anyway, I'm gonna solve this Fibonacci and then I'll get back to, I don't know, work or something today. Perhaps. So f of 5 is not less than 3. 5 is not less than 3. So we're gonna do the summation of f of 5 minus 1 plus 2 times f of 5 minus 2 plus 3 times f of 5 minus 3. How did I solve this last time? So when I did it for 4, okay, I expanded it into steps like this. And then for 3, is it useful maybe? I think maybe I like that. I think I'll only expand it that way if it gets too long. So that's the same thing as saying f of 4 and 2 times f of 3 and 3 times f of 2. Let's see. So in that one, then I broke it down. Let's see. And the one before, f of 2, f of 1, and f of 0 are all simple, so I didn't have to expand anything. But this one I will have to. Yeah. What even is the Fibonacci formula using? It looks like regular math one might be different form. I'm not currently working on the Fibonacci problem, but the Fibonacci like sequence uses tree recursion. I'm doing a different exercise that also uses this tree recursion. So I keep talking about Fibonacci numbers because it's like, in a way, it's like a simpler case. It's right here. It's just, you know, yeah. No, it's not your mistake. Frank Hester also, so Fractorial I sometimes talk about as well, because all of these are examples of like types of recursive uh recursive procedures that can be written as recursive processes or iterative processes. So factorial is another example. That's why they're on like this side. Because basically, for factorial and the Fibonacci numbers, the book solves it for you to discuss it. But the way they solve it, and I guess I'm missing some logic. I don't understand the jump exactly from recursive to iterative. And that's what I'm trying to like deduce for myself. I understand a little tiny bit that with the recursive process, you take this is this one like up here. You basically just do the you do the function, you call the function calls itself. So you have factorial n, and then later it calls factorial n minus 1. So it's like do the same thing on this thing again and again and again. Iterative can do the same exact thing, but it's a slightly different process. It's like instead of calling the function factorial uh again, it figures out what is the step that needs repeating, and then it says do this step as many times as you have to repeat this step. But they both work out like they're both two ways of solving the same problem. And apparently there's some like mathematical theory that all recursive problems can be solved iteratively and vice versa. And I don't know enough mathematics to understand why that is or how that is. But what I want to be able to do is I want to be able to take any recursive function and kind of like deconstruct it and turn it into an iterative one. But I don't understand enough. So, like, there are tools that make this easier because recursive functions to me just seem more understandable and readable. So then you have things like, yeah, loops, like literally loops. Like, that's the whole thing. Like, it tells you something like do this thing this many times again and again and again or whatever. But I haven't learned loops yet. I just have if, like, so I could use if. Um, I know basic conditionals. So that's another thing I don't fully understand. Like, I don't understand why cond in scheme can be used. Cond else can be used for recursion, like as a recursive process. But then if is kind of different. I guess it has to do with, I think it has to do with the method, right? Like conditional, what's the difference between these two? The conditional states that if n is 0, do this. If n is 1, do this. Otherwise, do this. And the iterative says if count is 0, b. And then otherwise do this step. And what I don't understand is like I don't understand this step. I don't understand how they get I don't understand how they choose the parameters. I learned something about like for recursion to iteration, you need to keep track of the steps or like something like a stack. I don't know what a stack is. That's also new to my vocabulary. You also need, there are going to be things that you carry over from the last uh equation or the last iteration to the next one. Content if feel like they should be similar, don't know what's going on when it comes to scheme. I don't understand it either. It's okay. I'm gonna figure it out today. This is this is all I could think about last night this morning. So I'm not letting it go. Let's see. Anyway, F so this problem that I'm doing now is completely it's like a different thing. It's probably more similar to the fib maybe than the factorial equation because I think you know what? I think now that it doesn't matter because I just noticed that the factorial equation does use if. I think you just use if you only have two states. Actually, I have no idea in scheme. I think it's if you only have two states and then you can use cond if you have more than two like base cases. So that was like, yeah, that's a false flag. The stack is what you use to keep track of pointers. I don't know what a pointer is. The fast memory you don't use like the heap. I don't know what a heap is. There's also simple stack machines you can easily code and expand on. Again, I'm a beginner, so all of these things are completely new to me. And I think I should be able to solve what I'm trying to solve without that vocabulary. And then later when I get to that vocabulary, it'll make a lot more sense. So I don't really know I don't know how to talk about stacks and pointers and memory when I haven't gotten there yet. If that makes sense. But I understand. So like that's like the beauty I think of knowledge is that like the more you learn and know, things start to make sense later on and also you find like easier ways to do things and to explain things. So part of the reason I think if I'm not mistaken, I feel like one of the things they keep trying to drill is that when these like recursive functions can be more expensive somehow than the same process done iteratively. Anyway, um meow. I'm gonna just try to keep going, I guess, because I don't know. I don't know if I could say anything more. Of course it does. Of course the textbook says stuff about that. And I don't think it's so IDK. I don't think it's that scheme transforms tail or linear recursion into iterative functions like de facto. It's just something that can be done. Or unless I'm not understanding that. But yeah, it did I don't know the difference completely yet between tail recursion and linear recursion, but I did look like I looked at examples of linear recursion and then also now we're on tree recursion. But anyway, um So I would say also, like, if this is frustrating for you to watch, I'm sorry, cuz like this is just going to be part of the learning process for me. So, yeah. I hope you won't be too bothered if I kind of try to take my time and understand it. So, I talked about this on another stream. I do admit that um I don't think I have enough math for a lot of these things to come intuitively. So it's true perhaps that lambda calculus would be more clear. I don't know what you mean when you say it's purely functional programming because I'm a beginner and I don't know what functional programming means either. Aren't iter functions just loops? So while you haven't been taught loop structures, you can kind of replicate one with examples. Um, I don't know, Frankester. Probably. Probably. Maybe iter functions are like definitionally just loops. I'm saying I haven't learned the loop concept yet, so I don't want to like I don't want to. Sorry if I feel like I don't. I feel like I'm not making myself super clear. Yeah. I feel like you guys are trying to give me a way out, an easy way to solve, but I'm not looking for a way out or an easy way to solve. I'm looking for like a deeper understanding of what it means. Instead of focus on objects like what you're dealing with, the object being what you're iterating, changing. Functional programming is how data is being changed. Okay, thank you. I'll just say thank you. Yeah, okay, let's continue. Mm-hmm. Meow, 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 meow. Meow, 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 meow. Mm-hmm. Meow, 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 meow. I should do this on one line, but it's so confusing. Okay, that's 8, 11, 11 plus 8 plus 6. 25, 25, 25, 14 plus 1. Okay, I feel much better now because last night when I was doing this, I kept getting like 22 or 23, so I was definitely skipping some steps. I don't think it's the most like I feel like I shouldn't write it this way. Let's get rid of the let's just put things on one line so that it's easier to read. Meow. Meow. I mean, I don't think it's easier to read somehow, but let me think about this again. Brain hurts. My brain hurts. Add this whole chunk to this chunk and this chunk. Okay, that is right. And then we're adding this whole chunk to this chunk and this chunk. And then this. Meow, 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 meow. Meow, 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 meow. Hi, Spike. Hey, man, the exorcist. Oh, IDK, it's okay. I don't need you to solve it for me, by the way. It's okay. You don't have to solve it for me. I'm gonna solve it myself. And yeah, I learned a couple of times people, I kind of understand the base cases. But I don't want it to be solved for me, so I'm gonna try not to read exactly what you wrote. But yeah, I don't want it to be solved for me because I think part of the fun is learning, is like solving it myself. And anyway, so I did a lot of like, some of you might think I'm silly maybe for doing the, like, showing out all the work, but the reason I'm doing it is because I want to prove to myself that I understand fundamentally what's happening in the steps, and that way I can recreate the steps, I guess, programmatically. Um so I'm almost there. It wasn't really working out yesterday because I I kept I think I kept skipping something, um some parts of the steps or something. Okay. So, because I think basically what I've kind of, I don't know if this is wrong, but what I've kind the conclusion I kind of come to is that in order to in order to figure out what this like iterator needs to do to begin with, I need to know what is the pattern that's happening at each step. I already know the base case is that when n is less than 3. Meow. 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 Okay. So, I don't have the. Let me see. Let me pull up the book, like, or let me pull up the question. Meow, meow. Maybe I should make a sticky note. Maybe I should do a sticky. Let me do a pinned message, I mean. Um, meow, 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 meow. I will share with you guys what exercise I'm working on. Um, let's see. Right here. Didn't mean to press that. I want to remove this. Man, man, man. Man. Oh man, the thing stay right here for me. Stop moving around. I don't need you to move around. Okay. I'm gonna move the server. I don't think I need this one anymore. Close this. Let me go over here and over here. Maybe. So we have a function f of n, and I need to write a procedure that computes f by means of a recursive process, and then write the same procedure, write another procedure that computes f by means of an iterative process. So I've already done the recursive one because that's like very easy for some reason. Man, it's not fair. Why is the recursive one always? I don't know. Not always, but it's definitely more human readable. But the using an iterative process is where I'm a little bit stumped, and here's why. The reason why I'm stumped is because every time the book talks about it, right? There's there's like A B count, and I'm like, where the heck did count come from? And then what the fuck is this? What is this? What is this? And then if we go back far enough, to the basics, let's see. We could look at factorial. So factorial, doing the linear recursive process, it like kind of grows in this way when you have it done uh recursively. It kind of grows and then shrinks. But when you iterate, when you do the iterative process, you have like something, I don't know what they call it, but like states. And then you just like change the numbers. You like save it and update. You save a state and then you update it and then you do the step again. Something, something, something. Right. But my question is basically like this part of it, like creating the iterative function, does not come intuitive to me. It doesn't come intuitively to me. I don't understand how they figure out that so for the factorial, we need to multiply n times the factorial of n minus 1. Okay, I understand that because that's math. But how does that translate to this whole thing where you have a product, a counter, a max count, and then you have like if the counter is greater than the max count products, and then you have multiply the counter and the like I don't understand how this comes from the same problem. So that's the part I'm trying to understand. How do I turn a function into an iterative process? Like what's the logic? Now, there's a chance that this could be maybe this is a math issue. Maybe I'm missing the kind of math that makes turning a function into an iterative process like simple or easy, or maybe it's just a hard thing to do. But one of the things I was thinking about is like, okay, what are the actual steps that are happening, right? So the Fibonacci number was like an easier way to look at it too. This is another example, but this is tree recursion. And when you look at the sequence, you can see the pattern. You can see that for a number that's not 0 or 1, you need the previous two numbers and then you add them together to get the next number, right? And then you have a number and then you take the previous two numbers and you get the next number. And then you take the previous two numbers and get the next number. So that helps. What I'm trying to say is like this makes sense to me. Like there's like I see the steps. And then I understand that somehow this Fibonacci iterator is doing that, where it's like it's transforming uh it's transforming some numbers. Let me think about this again. So we have A and B and count. When count is 0, B. Otherwise, add A and B, and that's going to be the new A. And then put an A for B, and then the count is going to be decremented by 1. So I don't understand this part. Like I don't understand how 1 comes up with this part. But I do see that it's basically counting down. I guess if we use an example, like if we want, let's say n is 2. If n is 2, we're gonna do fibiter on 1, 0, 2. So this is 1, 0, 2. If count is equal to b, well, 2 is, if count is equal to 0, then b. 2 is not 0, so it's not b. So we have to do this part. So a and b is 1 plus 0. A is 1. And then 2 minus 1 is 1. So we have 1, 1, 1. And then we put it back into fibiter. In here, actually. So 1, 1, 1. Is 1, 0? No. So we put it in here again. And we have 1 plus 1, we get 2. 1. And 1 minus 1 is 0. So 2, 1, 0. And that goes in here again. 2, 1, 0. And then it says, is count 0? Yes. So then the answer is B. Or so we print B. It's hard to do this in my brain out loud instead of writing it down. My brain really hurts. Meow. Meow. I'm trying to think. Is Fibonacci 2 1? Is that the actual answer? So we can use the function to decide if that's true. So fib of a number is the same thing as fib of n minus 1 and fib of n minus 2. My brain hurts. My brain hurts again and again. Anyway, so if we're doing 2, 2 minus 1 is 1. Fibonacci of 1 is 1. 2 minus 2 is 0. The Fibonacci of 0 is 0. So 1 plus 0 is 1. So fib of 2 is 1. Right? Anyway. You know, words. Words. I'm getting upset again. I don't want to get upset. I just wanted to prove to myself that you can I don't know, you can do the math without writing out all the math. So in this case, f of 0 is 0 because when n is less than 3, it's just n. So for 0, 1, and 2, it's just gonna, the function is just going to output itself, right? But then when we get to 3, why is it 4? Because since it's greater than or equal to, n is greater than or equal to 3, we have to do this function, or this whole process right here, right? So 4, it's just another way of saying we need to take f of n minus 1, so we're at 3, so that's f of 2, and then we're going to add it to 2 times f of 3 minus 2, which is 1. And then we're going to add that to 3 times f of 3 minus 3, which is f of 0. And that's the same thing since we already solved them. These are already solved for us, right? It's like the previous. So we're Fibonacci looks at the last two sequences. This problem looks at the last three because we're looking at n minus 1, n minus 2, and n minus 3. So we're looking at the last three. We take the previous and add it to 2 times the one before that and add it to 3 times the one before that. So that's the same thing as saying 2 plus 2 times, like 2 times 2, which is just 4. I don't know how I should write this. Maybe like this. Plus 3 times. Wait. That's not 4. It should be 1. Sorry, let me go slower. 2 times f of 1. F of 1 is 1. Plus 3 times f of 0, which is 0. Man, man, man. And that's also the same thing as saying 2 plus 2 plus 0. And then we get 4. So my argument to myself yesterday was that instead of writing out all of the things, as long as if you know the sequence, you can like basically I want to know the sequence so I can calculate the steps, right? So f of 4 should just be f of 3 plus 2 times f of 2 plus 3 times f of 1. Which is the same thing as 4, because f of 3 is 4. We just solved that. And then 2 times f of 2 is 2. Now it's 2 times 2. Which is just 4 again. And then 3 times f of 1, which is 3 times 1, which is 3. And then we get 11. And then if we do f of 5, it's f of 4 plus 2 times f of 3 plus 3 times f of 2, which is f of 4 is 11 plus 2 times f of 3. F of 3 is 4, so 2 times 4 is 8 plus 3 times f of 2, which is 2. And 3 times 2 is 6. And then it's 25. So theoretically, we could do f of 6. And then we should get, let's see, f of 5, which is 25. I'll just write it first. F of 5 plus 2 times f of 4 plus 3 times f of 3, which is 25 plus 2 times 11, which is 22, plus 3 times f of 3, which is 4. 3 times 4 is 12. 33 plus 25, 50. It'd be 9. Wait. 34. 59. And then since okay, I haven't figured I do know how to do this with the recursive process. I did that yesterday. Oops. I just haven't written the iterative process, but we can use the recursive one to check the answers, right? So let's just double check this is working. F of 0 should give us 0, and it does. F of 1 should give us 1. F of 2 should give us 2. F of 3 should give us 4, and it does. F of 5, F of 4, this is 11. F of 5, 25. And let's see if we are making sense. Yeah, F of 6 gives us 59. So yeah, we did do that one right. I keep trying to go backwards and forwards on the chicken interpreter, but it just prints the keys, I think, instead of the arrows. Anyway, I want to put this in here. 59 is equal to this nonsense. Anyway, I'm gonna take a look at chat now. I haven't been reading for a little while. Meow. Hi, sheeple. In what case would you not use a loop, instead use this? This is not the point, Z-Chair, by the way. This is not the point. I don't think the point, or at least I don't know right now. So, like, because I'm not a programmer. I'm just a beginner. I'm still on chapter 1. My point isn't saying, like, oh, there aren't easier ways to do this using loops or whatever. I'm just trying to, like, I'm trying, you know, like, I don't know how to explain it to you. I don't know how to explain to you that I'm just, like, trying to solve a problem here. That's all. Identifying the logic, keeping track of the last 3 values is pretty similar. Yeah, so I know that this is the same, like, pattern, right? I just don't know how to turn it into an I don't know how to turn it into something beautiful like this, but I'm gonna figure it out, and that's what I'm here for. So, do I still have that thing from yesterday? Let me see if I can find it. Found some steps on the internet because it doesn't seem clear here. Actually, I go back to the book first. Let's go back. Let's just try here. We can also formulate an iterative process for computing the Fibonacci numbers. The idea is to use a pair of integers, a and b, initialize to fib1 equals 1 and fib0 equals 0, and repeatedly apply simultaneous transformations where a plus b becomes a and a becomes b. It's not hard to show that after applying this transformation n times, a and b will be equal, respectively, to fib n plus 1 and fib n. Meow, 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 meow. Meow, 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 meow. Let's go back here. Consider the pattern of this computation. To compute fib 5, we compute fib 4 and fib 3. To compute fib 4, we compute fib 3 and fib 2. In general, the evolved process looks like a tree. Notice that the branch is split into 2 at each level, except at the bottom. This reflects the fact that the fib procedure calls itself twice each time it's invoked. Where's figure 1.5? It's down here. So fib 5 requires these two, fib 4 requires these two, and these require 2 until they get down to 1 and 0. Okay. This procedure is instructive as a prototypical tree recursion, but it's a terrible way to compute Fibonacci numbers because it does so much redundant computation. Notice in figure 1.5, the entire computation of fib 3, almost half the work, is duplicated. In fact, it's not hard to show that the number of times the procedure will compute at fib 1 or fib 0, the number of leaves in the tree, in the above tree in general, is precisely fib n plus 1. The number of times the procedure will compute fib 1 or fib 0. So for fib 5, we have fib 1, 2, 3, 4. I don't get it. Wait. The number of times the procedure will compute fib 1 or fib 0 is precisely fib n plus 1. So if we take fib 3, I don't get it. I don't understand this. Uh, I don't understand this part either. um, um. 1, 2, 3, 4, 5. 1, 2, 3. I don't understand that. One. Meow, meow, meow. 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 I don't know what this. I think I'm not understanding what this means. Meow, 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 meow. My brain hurts. I think I need a break again. I think I need a break again. Where's my thingy? So I asked Perplexity yesterday to help me make a rule. Where is it? Where is it? Where is it? Define the precise mathematical description of a state. Keep a finite collection of states. That's all I use for. This is why I threw this out last night. Man, 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 man. I want to cry. Okay, this is what I was looking for, a recipe, but I don't know if it works. Identify the base cases. These are the conditions where no further calls are made. So when n is less than 3. Identify the successor arguments. For each recursive call, write down explicitly how arguments change. How the arguments change. Linear from n to n minus 1. Tree from a node to its children, or from an interval AB to subintervals. I don't understand this. Define a state object. A state is a tuple. Okay, this is garbage. I'm throwing this out. It's not garbage. I don't understand it. That's all. I'm garbage. Meow, meow, meow. Oh, I'm so stupid. I understand it now. Okay, I misread it. That's what it was. So it says that. Oh God, why am I like this? Why am I like this? I'm so stupid. Listen. Okay, I shouldn't say that, but I misread this. So I was confused because I thought it said that. It says the number of times the procedure will compute fib 1 or fib 2 is fib n plus 1. I thought it just said n plus 1. So I was like, why the heck? Because like I was like, I thought fib 5 would call it 6 times, but fib 5, what you said is correct. That fib 6 should theoretically be 14 calls. Wait. 3, 4, 5, 6. Is it 8? So it's only zeros and ones, I think. 1, 2, 3, 4, 5, 6, 7, 8. That's where they got that from. I was really confused. Yeah, they're only counting fib ones and fib zeros. I was like, what the heck does this even mean? It's not hard to show that the number. That makes a lot more sense. That makes so much more sense. Yeah. Yeah. Um, Let's see if that checks out. Fib2 makes two calls of fib1 and 0. So that means fib3 should be 2. Is that true? Is fib3 2? Fib1, fib2. That doesn't seem right. My brain hurts. My brain hurts again. Maybe it doesn't work. Maybe I don't know. What the heck is fib3? My brain is melting. It'll click someday. It's just maybe not today. Maybe next week. The book is showing you the lowest way to build up. Yep. I'm having fun, by the way. Even though it sounds like I'm in pain, I'm enjoying it. I think I need more math, but I'm still enjoying it. I have fun. Let's have fun. Meow, 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 meow. What? 0. 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Because that because plus else undefined. Okay. Brain hurt. Fib 4 is 3. So Fib 4 is 3. So Fib 5 is 5. So Fib 4 should call 1 or 0 5 times. Let's see if that's true or if this book is lying to me again. 1, 2, 3, 4, 5. Ah! Okay, it works. I wonder if that leads to. I read this whole chapter already. I read the whole chapter already. So anyway, the reason I wanted to talk about this, though, the reason I'm highlighting this, I agree with what you're saying, but that's the obvious point. The obvious point is talking about why, the difference between recursive processes and iterative processes, and why, like how each one computes to the same thing but in a different way, right? So that's where that's going. But the reason why I brought that up, though, is because in in the iterator down here, it talks about it's not hard to show that after applying the transformations n times, a and b will be equal respectively to fib n plus 1 and fib n. And I wanted to know why they were looking at fib n plus 1 anyway. A and b will be equal to fib n plus 1 and fib n. Meow, 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 meow. Anyway, I don't know if I should. I don't know how much I should read chat because I feel like I'm just gonna get more and more and more confused if I keep reading chat too much. Man, man, man. The idea is to use a pair of integers a and b initialized to 1 and 0 and then repeatedly apply some transformation. So this 1 and 0 is like starting at the bottom, I guess. Meow. I know, I'm more saying it to myself. It's my urge. It's my urge. Yeah. Okay. We're gonna get down to the bottom of this. We're gonna get down to the bottom of this. Meow, 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 meow. meow, 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 meow. Meow, 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 meow. Wow, 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 wow. At each step, we need to keep track of, for any n, are the current values of the variables. Meow, meow, meow. A fixed number of state variables together with a fixed rule that describes how the state variables should be updated as the process moves from state to state, and an optional end test. Blah, 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 blah. We could describe a rule for computing n factorial by specifying that we first multiply 1 by 2, then multiply the result by 3, then by 4, and so on till we reach n. We maintain a running product together with a counter that counts up from 1 up to n. We can describe the computation by saying that the counter and the product simultaneously change from one step to the next according to the rule. Counter times the product and the counter goes up by 1. Meow, meow. Meow, 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 meow. Brain hurts, brain hurts, brain hurts. Mhm. Mhm. Meow, meow, meow. Ah, 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 ah. One reason that the distinction between process and procedure may be confusing is that most implementations of common languages are designed in such a way that the interpretation of any recursive procedure consumes an amount of memory that grows with the number of procedure calls, even when the process described is, in principle, iterative. As a consequence, these languages can describe iterative processes only by resorting to special purpose loop constructs such as do, repeat, until, for, and while. So this is exactly the problem that I'm having right now. I'm trying to find out the underlying logic, but so many languages use loops and these things, do, repeat, while, whatever, to do things iteratively, to kind of like, I guess, avoid what I'm trying to do. So I'm having trouble finding good instructions on yeah. Scheme will execute an iterative process in constant space, even if the process is described by a recursive procedure. An implementation with this property is called tail recursive. I see. With a tail recursive implementation, iteration can be expressed using the ordinary procedure call mechanism, so that special iteration constructs are useful only as syntactic sugar. Tail recursion has long been known as a compiler optimization trick. A coherent semantic basis for tail recursion was provided by Carl Hewitt, who in 1977, who explained it in terms of the message passing model of computation that we shall discuss in chapter 3. Inspired by this, Gerald J. Sussman and Guy Lewis Steele Jr. constructed a tail recursive interpreter for Scheme. He later showed how tail recursion is a consequence of the natural way to compile procedure calls. The IEEE standard for Scheme requires that Scheme implementations be tail recursive. Meow, 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 meow. Ackerman's function. Bleep, 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 bleep. Yeah, I've used Perplexity. I've used Perplexity a bunch, and the problem though is that it's so Perplexity doesn't know, and ChatGPT doesn't know. They're just scraping from other sources, right? And so many other sources all say the same thing. Like when the issue is that like it's like a fundamental one, right? When I look for how to transform recursion into iteration, use a loop. Use a loop, use a loop, use a loop. That's like the most common answer because it's probably the easiest way to solve this problem. But there's like a step below. Basically, I think what I'm doing is using a loop, but it's just not calling it a loop. If that makes sense. It's like, you know, like, I don't know if that makes sense, but that's what I think is happening. Aspect 242, I think, are you trying to roast me? So yeah, yes, yes, yes. You know, I didn't. It's not easy. It's like a hard. It's a hard book, but yes, exactly. Z share. So I feel like the loop is the abstraction above whatever it is that I'm looking for. So loops are like the useful abstraction, but I'm trying to look for the underneath. I'm trying to figure out how are they getting this? Like there's definitely a way. I think maybe it's like a math thing. There's like something I'm missing here. Meow. Meow meow meow. Yeah, so like please don't tell me to go do something different or something easier or whatever, because I don't want to. I don't want to. I want to do this. I do this. But what I also will do though is I will take my time. So I'm not gonna like beat myself up. No, no, no. It's not that it comes off as roasting. I'm just saying. Mhm. Mhm. It's like I just want to learn the fundamentals. Yeah, exactly. Thank you, though. Yeah. Um. Oh, thank you for reminding me of that, because that's what I was gonna go to next. So a spin-off of this book is still being used at Berkeley. I wonder if they have something. Yeah, I know. Yeah, MIT has stopped using the book, but UC Berkeley is using like a remix of the book. And I was doing the UC Berkeley course first, but then I got curious. Let's see. It uses Python instead of Scheme. Um, Meow. Yeah, I'm not paying attention to the language, don't worry. I was just looking to see, I wanted to double check to see if they talk about um recursion and iteration more, but it doesn't really look like they do. Oh wait, here, 1.55. Let's see. It's interesting how similar it is, though. Yeah, I'm coding in Scheme. But I'm not looking for the it's not about the language. It's about like figuring out what variables, what arguments are needed and what needs to be done to them. I don't know how to I don't know how to like quickly identify that. Or not even quickly, just do it at all. Okay. Okay. Like, is for the Fibonacci, is it 1, 0, n because of the base case? Is that the reason? Um, is it because of this base case where n equals 0 and n equals 1? I have to meow, 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 meow. I think it is, yes. Okay. Because okay. Because our base case is if n is less than 3, then it's n. And I'm wondering, is that the same thing as saying n is 0 when n is 0, 0, when n is 1, 1, when n is 2, 2? Is it the same thing? And then therefore would that mean that do I need like 2, 1, 0 and an n or an equivalent? I don't know. Oops, I put it in the wrong place, but I don't understand how they get that part. I don't understand how they decide what the arguments of the iterator are. Like what the arguments or the parameters are. I don't understand. It's 2 and 0 are the three values you initially need to keep track of. Okay, maybe. Let's try it. Let's give it a go. So then I wonder if I can do this if I can build this the same way with 4 parameters or if it's gonna get weird. If count is less than 3. See, but I can't do that. Actually, I can, right? Wait. Meow, 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 meow. I gotta think about this. My tummy hurts. I'm hungry. Meow, 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 meow. Meow, 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 meow. Meow, meow, meow. I need a break. I need a break really bad. I will stop this for now. And let's avert changes and let's get out of here and let's yeah. Okay. I come back to it. It's the other interesting thing is that like every time I try to look it up for Scheme, it's kind of like the book is kind of the only reference for it, and they just every other website that's showing an example is just showing the same exact examples that the chapter is showing. So I'm just like, that's interesting. Like they're all referencing the same thing. So it's hard to find like new information. There's definitely a mathematical way to do this that I'm missing out on. Okay, I'll be right back. I promised myself for 2026 I'm not gonna hold my piss. So I'm gonna go take care of that. That's okay. It's so fun though. It's cool to look at and it's pretty fun. Anyway, I'll be back. I'm gonna be AFK for a bit. Thank you guys for um researching with me and trying to help me and for just visiting. I appreciate you. It's really cute. Yeah, I'll be back in a little bit. I'm sorry, I didn't mean to crack your skull. The other thing too is there's probably a very simple way of looking at this, and I might be like, because I don't know what I don't know, you know. Hi Tim, I'll be back in a little bit. I didn't realize I had muted myself. That's really awkward. Meow, 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 by the way, meow. Um, I just finished reading A Mind for Numbers like a week couple weeks ago. And it's about like how we learn and the different ways we do that. So, I do think that getting away from the problem and letting my mind kind of like make connections in the background is probably for the best. But I do tend to like get hyper focused and like it's like I can't stop thinking about the thing, but I feel like if I get away from it a little bit, maybe I can come back to it with like with clearer eyes. Um because I don't believe it's magic, right? I think the authors of the chapter are doing something and I just don't understand what they're doing. I don't understand how they're doing that. I don't like I kind of get it a little bit like theoretically. I understand that. Basically, I need to figure out what does one step look like, right? I need to figure out what does one step of this function look like. And then I need to figure out if I'm starting from 0 or if I'm starting from if I'm starting from 0 and counting up or I'm starting from n and counting down. And then between each step, what are the variables and what's changing? Because once I know what variables are changing in one step from one step to the next, then I can write the process as like here's the step, repeat this step. But I think I'm missing something. I'm missing a jump from like how you turn that whole function into just one like mathematical step. Especially with tree recursion because it's like the function calls itself more than once. Like it's not in a line, right? Yeah, it's like building up the tree. So I think I understand it like put a number in and check if that number is less than 3. If the number is less than 3, then you print that number, whatever that number is. If the number is 3 or more than 3, then you're going to break it up into parts and add those parts together, and you need the like past 3 like yeah, n minus 1, n minus 2, n minus 3 of the function. But I don't know how to turn those words into like I don't know how to turn those words into variables and parameters and a count. So I have to I don't know. I think I need to let it yeah, I leave it alone for a little bit, but I'm just yeah, ranting again or rambling again because it's on my mind. It's on my mind. And I do think that so far the exercises have been written in a way where like you have what you need to solve them. So I don't think they're just going to suddenly be like, "Oh, by the way, use loops." Because we haven't covered loops yet. So I think it's like with the tools that we already have, I can definitely solve this. I just don't understand how to. Meow, 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 meow. Anyway, I'm gonna be watching a little bit more of the dating show. Then I'll get back to some work. I'm gonna read books and stuff, but a little later. So I take a break. I'm gonna set a timer for I don't know, 30 minutes. I give myself half an hour break. It's so interesting too though, cause like thinking a lot, it makes me so hungry. It makes my brain my brain is just like, give me nutrients, please. Please. Hi, Owl Night, how are you? Good hello to you as well. Meow meow. Hey, let's play. Knowledge eats up all the food in the body to make more room for knowledge. Yeah. Meow. I was gonna take a longer break, but I think I'm done now. No more break. No more break. Um, um, um. Let's see. Okay, maybe I take a break. I don't know. I think I should, but I'm gonna play egg game. Let's play egg game. Because I just looked at my schedule, and 4 to 4:30 is supposed to be a break anyway. Meow, meow, meow. Meow, 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 meow. Meow, meow. Meow, 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 meow. Meow. Wah, wah, wah. Whoops, whoops, whoops. It's today the day where Harold gives me no, titanium tiara. That's even better than icy tiara. I wanted the steel tiara. Yay, 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 yay. Sorry, I got excited. It's better than icy tiara. I could use it on my petulance. Meow, meow, meow. 300k. I could do it. I could level it. Why do I have so much crit though? Use this one instead. I'm excited, I'm excited, I'm excited. I've wanted that headpiece for a long time. Meow, 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 meow. Meow, 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 meow. How much damage does it do? Let's see. 90k. That seems to do that much. Goes too fast. Wait, let's go slower. 72k, 7k. Ah, that's like really not good. 7k damage on 7 million HP. Not not great. No, that's not the guy that's supposed to drop the scarf. So this guy is like the daily boss, and you can like you fight him every day. If you fight him even once, you get like a chance to get some items. If you can beat him, then you get items, and then you get another chance to try to beat him again, and his element changes. So like I didn't beat him, but I can still get rewards. And then if I do like the better you do, so right now level 61, that means I have a chance to get like rare items, which are like kind of low. If I do better, then I get a higher chance for like the better rewards. And then same thing I think with 63. Just higher chance. So this daily guy Bogar gave it to me. The one that I need to think from is Harold. This fella. Meow. Meow 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 meow. Meow 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 meow. I beat a boss yesterday on my main account that I was having trouble with. Cause I was trying to brute force it without really paying attention to mechanics. But that boss, if like he shields himself, but if he attacks while his shield is up, he does a lot of damage, and he would like wipe out most of the team. So I realized I had to like save my damage for when his shield is up, so I could get rid of his shield. Oops. Yeah. Oops. I have an account on my phone and an account on my tablet. Why no work? Why no work? What did I break? Oh, there we go. I didn't get it. I didn't get it. Try again. Maybe he meant to give it to me. He just forgot. Come on, Harold. Be a good kitty. Please, please. There's like a referral system, right? And if you refer friends, you get more eggs. So like someone referred me to this game, and then I let them get more eggs. But I don't wanna tell the Moonies to use my referral code because I don't wish this on anyone else. I am addicted to this. He's gonna drop it this time, right? I hope so. Please, 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 please. Nope. He hates me. He hates me. He hates me. Harold, why do you hate me? Harold, I just want the jellyfish scarf. Just give me the jellyfish scarf, Harold. Man. It's actually almost Do I have keys? Yeah, let's go. I'm gonna spend 400 gems on more keys. I really want it. It's funny how, like, basically it's such an overpowered item that it makes the floor levels with the regular monsters really, really, really easy. I need it. I need it. It's overpowered. I need it. Please, please, pretty please. I'm actually afraid he's gonna give me a legendary item, but a different one. I don't want a bubblegum scarf. I don't want a chef's hat. It's called Void Pet Dungeons, but I don't wanna shill it. I don't wanna share it. I don't wanna tell you guys to play it because I don't like it. I hate the game. I hate this game. I can't stop playing it, but I hate it. Okay, whatever. Don't give me the thing. Don't give me anything. That's what I deserve. Man, man, man. Yay! I got something new. Base damage. Not that good for Mary, but it's okay. I'll take it. Let's see. We'll level up Spite. And then we ascend our gear. And then I have to level up. Actually, I think I already leveled up the tiara, so we're good to go. I should level this up too a little bit, but I think we're good to go. Oops, I pressed the wrong button. Attempt a floor. Oops. Um. Meow, meow, meow. Uh-oh. Uh-oh. That's not good. This is not good at all. Sugar. Well, well. Awkward. Man. Hmm. Meow, meow, meow. Hi, kitty pitter. Can't believe he keeps killing my team like this. Gotta get rid of him. Wait. Okay, we put you in termination. And then we put in, let's get a on you. And then let's go with this one. Stamina. I don't know if that's gonna be enough to survive. Please. Okay, okay. Not great, but better. Much better, much better, much better. Come on. Come on. Come on. Come on. Ah, ah, ah. So close. So close, so close. Meow, 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 meow. Oh. This is so awkward. Wait. What if? Wait. Let's speed and crit. Hmm. What if we switch this one? Hum 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 hum. What if? Meow meow meow. Oh man. Oh man. We're so close. We're so close. Yeah, we're pretty close. Is there anything I could level up that would help? I only have 5 minutes left. Well, that wasn't supposed to happen. I need to use this. How are you? How are you? I need to get a K-cat. What's going wrong? Let's try speed. Meow, 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 meow. Meow, 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 meow. Let's see what's going on here. What's going on here? Meow, meow, meow. Yeah, the K-cat and the Halo. Ah, man. That almost works, but not quite. $700 feed. Meow. It didn't do enough numbers. It doesn't hit hard enough. Man. Ah! Thank you. Sakukoberg 2697. I'm not trying to pay my debt from streaming, but I understand that it's probably your first time here and you don't have context, so I'm not going to call you an idiot, but I am thinking that you're an idiot. I'm not trying to pay my debt from streaming. I'm trying to learn skills while I stream and build a business. I just happen to be streaming the process of getting out of debt. You know? And I just happened to be on a break, but I am 2 minutes over my break, so I have to get back to work. So thank you, though. Thank you for the wake up call. Man. Man. Okay. I don't know. Let's we go back to work. We go back to the grind. We go back to the grind. And then for this section of the stream, we put the kitty cat where she belongs. In jail. Get out of here. Get out of here. You're gone, buddy. Meow, meow, meow. Meow, 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 meow. Oh, the wisdom today, Fisty, is that Marcus is thankful for his body not giving out, considering the way he lived. And then I was thinking that yeah, it's like the gratitude thing has always been a weird one for me. I think I understand why you're supposed to be grateful for what you have and not take things for granted. I understand that you're supposed to do that, but I can't say that it comes automatically. And at some points, it's definitely just a way, it's like a way to cope. It's a way of saying that, I don't know, it feels almost invalidating. It's like, if I say my life sucks, and then I go, oh, but it could be worse. At least it's not worse. I mean, it's true. Like, it's true that, okay, at least it's not worse. But does it really make me feel any better? Or is it just like a momentary distraction? Or are perhaps maybe most emotions and feelings are, maybe that's all it is momentary distractions. So it's like, why hold on to the suffering? Just remember that, at least my body is functioning. Something. At least I have legs. I don't know. Seeing others' bodies fail them, realizing mistakes you made in youth could have cost you. Yeah, that's could be it too. Realizing, counting your blessings, something like that. Mm, I don't know. But it's interesting too, though, because there are people who have, physically less, but mentally more. I think my biggest weakness is definitely my mentality. And whenever I see someone who's like young, they get a diagnosis of like a terminal disease, and they really, really want to live, I feel like I should have switched places with them. Because there's like some people who really, really want to live and they really want life, and they're like good at things, and they're, accomplished. Maybe they have a family, maybe they have kids. And then life is too short for them. And then here I am with my body. And I'm just going on. And then, yeah, I don't know. An automatic reaction I developed, one which I have no emotional attachment to. Hmm. I got in the habit of thanking people when someone does something for me, but am I really thankful for it? Right? It's like you thank them because it's polite. I don't know. It's a weird thing to think about. Come on in, Tyler Bidwell. Oh. Yeah. Meow, meow, meow. But, but. Whatever. I understand that accent, Teak. I don't remember exactly what changed for you, but I know that you've said a lot of encouraging things, and I think you've also found like either community or places or people that make you feel, I don't know. Meow. That's all I could say right now is meow. Meow, 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 meow. Right now I'm reading. I guess I should write that maybe. Unpin. Okay. Meow, 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 meow. 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 I don't think it's weird, it's like whatever works for you. I think I spend a lot of my life like trying to ignore painful reality instead of trying to pretend that the painful reality is something good. Um, but not ignore it too much because I do want to change it. But I don't want to be preoccupied with it. It's a tricky game if you don't pay attention to it. If you escape too much, then it's hard to change the situation. But if you spend all your time like living in the agony of it, living in the agony, then you also kind of drain your capacity, your capability to change your circumstances. So there's like, yeah, it's like a rope. Yes, the appropriate amount of reality. Just enough of grass touching to, I don't know. No, I don't want to be your girlfriend. No, 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 no. No, I don't want to be your girlfriend. Commander K, I'm not convinced that you're an adult. Meow. It's mostly an endurance sport. Man, I'm losing this race. Even though I'm still enduring, but I also feel like I'm losing the race. Grats Poetse. We think that Galileo was a victim in the name of science. In fact, the church didn't take him too seriously. It seems rather that Galileo caused the uproar himself by ruffling a few feathers. At the end of the year in which Darwin and Wallace presented their papers on evolution by natural selection that changed the way we view the world, the president of the Linnean Society, where the papers were presented, announced that the society saw no striking discovery, nothing in particular that could revolutionize science. I'm enjoying this chapter so far. It's interesting. Okay, welcome back. I hope you had a good meeting. What are you whispering, Arco? More, it's less that his martyrdom was pushed by Big Globe, but more that, this idea that I was thinking about and we've been kind of teasing about and arguing about, the premise is, if you think that inventions we see around us came from someone sitting in a cubicle and concocting them according to a timetable, think again. Almost everything of the moment is a product of serendipity. So he goes on to talk about how this is the same conversation I was trying to have yesterday, the day before, where like there are these jobs and these roles where the goal is to plan or predict or forecast the future, but the things that end up having the like biggest impact are often not the result of some like meticulous planning, but some tinkerer somewhere working on something in a lab or an inventor, maybe for a company, whatever, just working on things and then stumbling upon things. And then it's kind of like, yeah, and then even at the time when the discoveries are made, sometimes the true consequences are beyond our imagination. Which pages? I'm on page like 178. I'm in the beginning of chapter 11. Um, but yeah. I think it's interesting. I think it's really interesting. I do think there's definitely something comforting about trying to have a plan or a vision or a goal. But having a plan or a vision or a goal isn't the same thing as like knowing, you know, or even willing that thing to exist. There can be things outside of the control, you know, you know, like the example he starts out with is when he worked for some financial institution as a trader before um Russia defaulted, or like something happened to the Russian currency in 1998. And at that time where he was working, he was um the company he was working for got some group of guys together who were, yeah, supposed to like formulate a plan for the firm's future. And the point he makes is that these managers spent money flying all over the globe, talking to so and so, making predictions, making projections, talking about the vision, where the company is going. And then the default happened, and then there was like a meltdown and like ripple effects, and all of those people who were part of that that thinking cohort were fired within a month. Yes, 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 the 1998 financial crisis in Russia. So the point he's kind of trying to make, or is that we can overestimate our ability to predict, and then at the same time take those predictions too seriously, and we treat them as if they are real, and then in doing so we can sometimes fail to entertain like things, outside things that could happen, that yeah, that we haven't planned for, and just how big of an impact those like outliers can be. um I don't know, I think it's like it's very interesting. I like reading about it. I think it's interesting. I think I think the practice, and then the other point was that after all was said and done, if the business didn't, if the company didn't go out of business, those managers that got fired after the crisis would have been eventually replaced by another group of guys in suits who do the same kind of thing and try to make 5-year plans and 5-year predictions or forecasts. Even though the activity, it's like, yeah, words, words. I don't want to say it's completely frivolous because, yes, there's some amount of like scheduling and, you know, like keeping the wheels turning, keeping everybody doing a thing, you know? But, keeping everyone on task isn't the same thing as being able to like predict success. Another thing too is that, um, that particular company's most lucrative department kind of stumbled upon a particular set of transactions that were kind of like being overlooked before by accident, and they made a lot of money from that kind of by chance, and yet they make these predictions as if it's as if like they win the lottery once and they think they can have a meeting about how to win the lottery again. With the post-Soviet economy in Russia, was never strong no matter what they did. Mm. Yeah, that's a good quote too, Accent Geek. The difference between, yeah, I'll read it. They are actually preoccupied with accomplishment. They are so focused on whether they can do something, they never stop to ask if they should do something. They conveniently define such considerations as pointless. If they don't do it, someone else will. They have to leave their mark. Yeah, I'm enjoying this book. It seems to be playing with ideas around like our cognition, like how humans think and plan, um, and why sometimes it can be faulty. The post-fall, pre-fall economy was terrible. Interesting, interesting, interesting. I don't know that much about economics. I only read one book about economics so far. And um what I think is that, yeah, I think these things are very complex, but people try to retroactively assign some story or narrative to a thing that played out. And that's very different from being able to say in the moment what's happening right now or be able to predict what's going to happen in the future. But then at the same, so like, so even though based on history and like these unexpected events, we should be able to figure out, okay, guys, we can't always, you know what's we can't yeah, we can't know the future because things happen, unexpected things happen. In hindsight, you can build a case for why, oh, it was obvious the whole time. But at the moment, right? Pre-fall, the Soviet economy was mostly quota-based. Post-fall, Russian free market failure caused a political and economical crisis. Anyway, the other thing, what I'm trying to say as well is that we analyze these things historically to make commentary about the moment, like right now. Like, there's so many people saying, okay, we're doomed, we're doomed, we're doomed. The economy, it's bad, bad. It's gonna be really bad, right? Um, but aside from prediction, it should be that, like, if you know what's coming, can you avoid it? Or are you or are they all saying that every crisis is inevitable? And then anyway, at the same time though, you have financial advisors and people who even in the face of looming crisis are paid to give people advice about what to do, even though they themselves don't know the future. Because if they knew the future, like, wouldn't it be an infinite money glitch? Um, Oligarchs, Russia's economy could never fully recover, be a free market. I pray that good fortune finds you. Okay, thank you, real garbage. Good morning. I hope fortune finds you as well. If it hasn't found you already. Maybe it finds you again. The quote from Jurassic Park. Still relevant. Yes, it's fiction, doesn't devalue it. I agree. Unpredictability is a core problem in the book, which the engineers and businessmen consider too vague and non-actionable. Actually, Accentique, I feel like you just summarized this entire book that I'm reading in like 2 sentences. I feel like that's exactly what this is about. This is exactly what it's about. It's about like unpredictability and how people, especially in businesses, um they don't want to acknowledge what randomness really means, what unpredictable really means, because I guess it's less actionable. So instead, they devise like tasks and sets of tasks that they can do, and they do repeatedly, and it makes them feel better. And it also helps them like keep a ball rolling. But then, yeah, something, words. Kangu wa. If you got recommended this and you didn't want to be here, I think there's like a button you can press and you could tell YouTube you're not interested in the content. You can only avoid it if the people in charge listen and people aren't greedy. Number one reason the Soviet Union's communism failed is greed, and with humanity, you can never remove greed. Zeech here, that is exactly what I'm learning. I feel like I'm still really naive, by the way, but I was even more naive before. But yeah, it's like there's just there's so much greed in humanity, and I'm not saying that I'm absolved from it. I think I sometimes act very greedy myself. Um Thank you, Kanku. I'm sorry. Commanding MFB 132. Meow. The sudden rise of authoritarianism in the past year has been shocking. I mean, it did. I mean, some people have been. That's a perfect example of this issue, right? Where it's interesting because there were people for ages ago warning about this could happen in the future or something like this could happen in the future. Like a lot of people say we're living in 1984 now, but not every prediction happened exactly like that. And it didn't happen at the time that that they thought it would happen. And then also it's like that's part of it. You just can't know. You can't know when or how it's actually gonna turn out. And then for all the predictions that were right, there are probably a lot more predictions that were wrong from the same people or from other people. Those who have zero greed will die from never caring for themselves. The poetry, I know that's not true. Think about it, right? Kitties. Actually, never mind. That's a bad example because kitties can be quite greedy. But I'm saying if you're cute enough, maybe someone will take care of you. Not everyone's equally greedy. I know. Didn't think it would happen so quickly. Must be technology stuff accelerating it. I thought this stuff would happen in the next decade. The future is hard to predict with any meaningful accuracy. That's another. Thank you, Live Type. That's another summation of this entire book in like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in 10 words. Hi Bowie. Hi Bowie. How are you? Oh, the main guy criticizing the dinosaur operation is a mathematician. It's a proper techno thriller. I guess I have to read it. Um, Favorite twist in the book is a statistical misunderstanding by engineers. That's why I like found this set of books because I feel like statistics is not intuitive to me and I want to learn more about like how to get a feel for odds and how to behave more rationally. But I don't know. I don't know if I found an answer to that. Meow, meow, meow. Who's Sir Mac? Who's Sir Mac? Last 50 years failing to protect the citizens of their nations. Mm, mm. We forget about unpredictability when it's our turn to predict. That is why people can read this chapter and similar accounts, agree entirely with them, yet fail to heed their arguments when thinking about the future. That's another reason I like reading this, because it's so true. Even I'm guilty of the very same thing, where, like I talked about it before, but I'll use it as an example again. I've made a plan for like how I want my days to go, right? Even for this stream, what I'm gonna do in what order. And yet, there's like an unpredictable quality of life because I can't tell like when am I gonna suddenly have a headache? Or when am I gonna get to a point in the book where I'm really stuck on a problem and I don't want to let the problem go? So then I end up spending more time working on it and less time doing the other thing. So it's like, even though I lay out these perfect plans and try to predict, okay, by tomorrow I'll be done with this and the next day I'll be done with this, there's all these unpredictable things. So, like, that's a very low stakes example because I'm just like one person. Like, who cares if I said I was gonna have lunch at 2 o'clock, but then I ended up having it at 3:30. It's like not that big of a deal, but I'm a person, and then the people who are running important things are also people, and they also have similar, maybe not as many defects as I have, but yeah. Who said no plan survives first contact with the enemy? Helmuth von Moltke. Yeah, I think there are definitely there's a distinction between routine activities that if you can make allowances for most of the things that could pop up, and maybe you can have like a stronger set of predictions. But there are other things that are way more variable, and we don't know we don't know what we don't know. We don't know what's going to happen. But the other point though is that these people in high places, I hate to call it this because it sounds so cringe, but like controlling society in air quotes. People who are making really big decisions that are gonna affect millions, if not billions of people, they too are subject to the same kind of like blindness to unpredictability, and yet they treat themselves and they treat each other as if they're making perfect decisions and something like that, or as close to perfect or whatever. Meow, 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 meow. But I don't know. I'm not saying that I have a better method. I'm just saying that it's interesting. I think it would be cool to find like a YouTube financial channel, like a, they always say it's not financial advice, but then they talk about things anyway. It would be fun. It would be cool to find like a couple of those channels and just like keep tabs on what they predict is going to happen and see how many of them are right. Uh-huh. Mm. Yeah, aspect. Mm-hmm. It's interesting. It's interesting. I do it too, right? I do it too, because I'll say that like, ah, it's because the problem was too hard. Instead of saying that, no, I failed to plan for, this potential outcome. Year prediction review videos are always fun. Um, seeing like which predictions came true. But I feel like I don't see too many. I mean, I don't look for it, so it could be that. But I don't see too many people talking about the times they failed to predict something or that they were wrong in their predictions. I feel like they kind of just like sweep it under the rug and move on to the next thing. Good luck, good luck, good luck. Back testing. Ah, good morning, Malcolm. I keep forgetting to set alarm? Or is it going off and I just didn't notice? Eh, Um, I'll read a bit more then before I take a break. Thomas Watson, the founder of IBM, once predicted that there would be no need for more than just a handful of computers. That's funny. No? Because you just never know. You never know. Now today computers are everywhere and in everything. I have a computer in you know, all over the place. It's because you're not reading the book, so you don't understand um the context of what's being said. Okay though. Like whether it's cherry picked or not, the point still stands. Like there's a lot of different examples. You can read the book if you want to see some more. Or you could think about your own life. Mhm. Meow. Meow, 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 meow. Mm, I think that's nice. I'm listening to rain sounds, but yeah. I I know it's unpopular to stream without background, but I background music or noise, background music. But I myself don't always like the background music. And also, I have technological reasons, tech issues that prevented me from using them to begin with, and now I'm used to it. Hmm. And I think it's nice because, yeah, you can listen to whatever you like. Meow 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 meow. Meow. Um. Meow meow meow. Wait. Hmm. Meow, meow, meow. Uh-oh. I broke. I broke the kitty. Meow, meow. Meow, meow, meow. Meow, meow. Oops. Meow. Okay, so it seems that what they did was they started with describing a rule for computing n before they determined the next step. So this is for factorial. I need to describe a rule of how we get to the next step. Um, Hmm. Meow meow. Wah 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 wah. Wah 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 wah. Oops. 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 Okay, I think I'm seeing something. All right. If 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 we do this based on base cases, let me take a look at this again. So they start with 1 1. Their base case. What? Um. One product counter. Oh. We have if this is the product. Actually, I already have this. I shouldn't make it again. Let's go this way. Uh, okay, use this one. Fine. I just want to see something. Ah. Ah. Um. Nina Chica, how are you today? Any breakthrough? Commanding Nicholas. I think I have a breakthrough now. I think I'm having a breakthrough now, but I just want to double check. Did you just ink me? The heck? Anyway. I'm seeing why there wasn't a 0. And it has something to do with just my bad. Telling you, you can never have enough math. You always need more math. Combinatorics. Consistency. Factorial of 0 is defined to be 1 so that all usual rules for factorials, counting, and combinatorics continue to work smoothly, even empty cases. So product counter and then n. And then if we go to the tree recursion problem with fib, we get 1, 0, n, where 0 is the start. What is A? Meow, 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 meow. Okay. Oh, I'm not ready yet. I'm not ready to take a break yet. Okay. We maintain a running product together with a counter. The counter and the product simultaneously change from one step to the next according to the rule, where the product is multiplied by the counter and the counter goes up by 1. And factorial is the value of the product when the counter exceeds n. Oh. Meow, 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 meow. Huh, 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 huh. Let's see. I need to look at the steps and see what happens at each step. So, in f of 3, if n is 3 and a is 2 and b is 1 and 3 is 0, Let me think about that. What happens at each step? Mm, 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 mm. Hi. Meow, 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 meow. Calling who terrorists? Terrorists. Oh. Meow, meow, meow. Okay, how are you? When the n is 0, the counter is over the max count. So we just get 1. Hmm. Is n less than 3? Add meow 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 meow. I don't need a hint. Guidelines for your channel. I don't know what that means. What do you mean guidelines? Guidelines for your channel. Okay, bye. Anyway, right now I'm on the step of like trying to figure out what the rule is. I'm trying to identify the rule of how the base, the input changes. Um Actually, let's do the next one. I just want to see a couple more. The next 3, or let's go up to 10. I don't know how ridiculous that'll be. Let's just go up to 9. So f of 6 plus 2f of 5 plus 3f of 4 is 59 plus 50 plus 33 equals 110. Man, I'm telling you. I don't know if it's IBS. Hi people, how was your day today? Doing? 59 times 2, 108. What the heck is going on? Can I not use Can I not use a numpad? That's very strange. I'll have to see what I accidentally bound to there. They can't multiply by 2. Leave me alone. Leave me alone. I can multiply, okay? I can. It's just the numbers are getting bigger, so I didn't want to make a mistake. I just didn't want to make a mistake. F of 8 plus 2f7 plus of 6. I keep skipping all my breaks because I'm so locked into the 335 plus 142 times 2, since the chica won't let me use a calculator, is 284 plus 3 times f of 6, 59, 3 times 59, 3 times 9 is 27, plus 150, 170. I'm using Vim. I think I might have bound something to. Let's actually see. 1 second. Yeah, I am using Vim. I don't know. I think I copied someone's VimRC a long time ago, and then I just never changed it. It's probably one of the few native shortcuts. Uh, I can imagine you could disable them. Yeah, probably. um, the thing is, I'm not like your computers guys or your hardwares. I only have one processor and it's barely working, so you just gotta tolerate me, please. Okay. That's actually annoying me. Let me double check why. She's a woman. That's true. Um, the other thing too is I think something about solving this problem is upsetting my stomach, so I really gotta go use a litter box. But I want to solve it. But I promised I would, obey my biology and stop ignoring it. But yeah, I need to solve this. Let's see. Why on earth does using um the numpad in Vim cause is cause Using the numpad in Vim often sends different escape key sequences than the main keyboard. Vim interprets them as commands instead of plain arrow number keys, which makes the cursor jump to random actions trigger. Many terminals encode numpad keys as multi-byte sequences, starting with escape. For example, number pad arrows or numbers can look like escape bracket D, etc. If Vim sees the leading escape and either times out or matches it to mapping, it can treat the rest of the sequence as unrelated keys. So instead of move right, you might effectively send things like escape bracket D, which in normal mode are real commands. It gets bizarre. If your vimrc maps escape to clear search highlighting or changes timeout settings, the first escape of a numpad sequence can trigger out that mapping. Okay. I stop using the number pad as well. Anyway, I'll be right back. Wish me luck. Hopefully I don't fall in. Bye. I'm gonna bring my phone with me. If I take longer, it's not because I'm doing who knows what. It's because I'm playing Void Pets in there. I'll be right back. I beat Bogar on my main account, but now I'm just climbing floors. Anyway. Thanks. I told you. You don't believe me. Man. I was playing this on my phone. I did wash my hands though, cause it was yeah, I needed to wash my hands. Anyway, it's going well right now, as you can see. On this account, I have the jellyfish scarf, so it's like really powerful. Anyway, that's enough of my addiction. I don't show you anymore. Okay. Where was I? Oh, still lost. Still lost in the forest, in the trees, for the forest, in the trees, in the forest, and the trees, the forest, and the trees, and the trees, the trees, it's the trees, and the trees, and the trees. Ha 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 ha. So the rule for factorial is that you multiply 1 by 2, then that by 3, then that by 4. So we start with 1, and then we have a counter. So we have one that's a counter. We start with the 1 that's a product. Max count can be whatever n. It could be 6, right? If 6 is less than 1, then we multiply counter times product, so that's just 1. And then add 1 to the counter, so that's 2. And then the max count, so the count doesn't change. That part doesn't change. Then we get 2, 1, max count. The max count is still... Wait, no. 1, 2, 6. 6 is still less than 2. So, Multiply 2 times 1. Add 1 to 2, we get 3. We get 2, 3, 6. So this is this. This 2, 3, 6. This is this. This is this. This is this. I need to figure out some rule that does the same thing where I keep n as n, and then I have some counter. I don't even know if it's gonna be from 1 to n or n. I think it seems to be popular to count up to n from 1. And then some product. And then I look at the other one. Look at the other one. They do one for the Fibonacci. Yes, I did, I think. This is recursive, isn't this? Pre-recursive. Then, do they have a... Oh, they don't have one that's... Maybe we could make one? But I guess count doesn't have to stay the same, though. That was just in the case of the factorial, because it's linear. In the Fibonacci, the count does change by -1. So they count down in this one, so you don't have to... Well, yeah, n -1. So I'm wondering if I'm gonna do that, maybe to count. Meow, 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 meow. I'm thinking. Oh, there was something about n plus 1. I don't know what that means. What does that have to do with anything? N plus 1. Meow, meow, meow. 6, 7. Thank you, Mother Nature. Doing okay, I guess. I'm doing fine. I'm hanging in there. I'm doing what I can with what I have in the place of the man. You know, I'm about to hit half pity. Give me a legendary. Nope, it just gave me anger. Give me a legendary. Nope, it just gave me curious. Okay. I got some keys. I don't feel like it. Okay, I'll do it. I got this. I don't feel like it, but I'll do it anyway. I got a felt fedora. Attacks heal for 20% of damage dealt. Is that good? Man, I feel so annoying. Can't help it. I've been this way. Lady Gaga. Let's see, 25, 25, 21. Move this one up to 25 and make it the points through this. And then I get another egg, and now I level up a pet. I got another one. Where are you? Where are you? You level up a pet. Now, I'll get more keys. Level up an item. Oh, the floor that I actually don't want to reach. Meow, 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 meow. You may be wondering, have you always been this annoying? And to that I say, getting worse with age. It's getting a whole lot worse with age. Okay, let's see. Is this what we like? Is this what we like to do? This is how we like to do it? What if we swap all gear? Go this way, and then we take this one, and then instead of black spike collar, we use sorrow. Let's just try it. He's missing. We'll go with this. Missing some. Go with this. They didn't do life type. They didn't do factorials after. They started with factorials. I'm just going back because I realized that I didn't understand the iterative version of factorials deeply before moving on. So I thought that like maybe there's a clue in here that's gonna help me. Like I understand what's happening here, right? These are the steps. And then every step you have the factorial that you're solving for, the number of the step that you're on, right? And it terminates at 7 because of this if, right? When the counter is greater than the max count, then print the product. And then here you have the factorial adding up. So this is iterative, and it tells you information about the current step. And then I think you can draw a similar tree for Fibonacci's iteration or whatever using this 1 0 and 1 0 and 1 0 and She's too busy playing Void Pets. Tell her to get off the phone. Get off the damn phone. It's always the phone. It's always the damn phone. Okay, I turned it off. I get off the phone. Let's see. I'm trying to figure out the rule, man. I don't understand the rule. We can formulate an iterative process The idea is to use a pair of integers a and b initialized as fib1, fib0 to repeatedly apply simultaneous transformations where a gets transformed to a plus b and b is transformed to a. The rule is there somewhere. Might have to hire a professional to find it. No, don't say that. Don't say that. I'm gonna find it. I'm gonna find it. See, like, to me, there's like definitely logic in here. They're not pulling this whole thing A plus B and A out of like thin air. It's coming from somewhere. I just don't understand where it's coming from or how do I do that myself, right? So they initialized 1 and 0. Did they do that because of something about is it about the base case thing where it's because of the base case? N equals 0, N equals 1? This helps no one. It's okay. I'll see. And then let me look at this again and how it compares to this. Plus ABA minus count 1. Are A and B just this? A plus B? Is that what that is? Fib n plus 1 fib n. After applying this transformation n times, A, B will equal respectively. A and B? What is A and B? It's so using a pair of integers a and b initialized as Fibonacci 1 and Fibonacci 0. So like they just picked two parameters or they made two arguments. I don't know why it's two, right? But I'm like, okay, does that mean I need three? Because the problem I'm solving has f of n minus 1 and f of n minus 2 and f of n minus 3. So do I need a fib like 2, 1, 0? And the other thing too is that like in this case, in the recursive one, we have like these two base cases, right? But is n less than 3 the same thing as like is it the same thing as n equals 0, 0, n equals 1, 1, n equals 2, 2? Else this thing. So I'm wondering if that's like what's tripping me up, that this is written as like a less than count of 3, but I don't think it should matter theoretically. I think I just gotta go with the flow. Alright. So the base case input is like asking, is n less than 3? So is this count? So here it's just asking if the count is equal to 0 though. And B. But that's because it's the situation is different. Meow, 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 meow. Like, what I'm wondering is if this whole conditional could also be written as, like, instead of 0 and 1, could it not just be written as if n... Oh, wait, it can't be, because it's different. Wait, let me think about it. If n is less than 2, n. B also equals A at one point. That's because, okay, so the reason why B equals A is because because every time you add, every time you do another step, you input that. So you start with, so we start with 1, 0, n as the base case. And if n is not equal to 0, then we add A and B together to get a new A, and then we move A over to B. So, like, instead of it being 0, B is now 1, and the count goes down by 1, and then we do it all again. And n be negative. 0, 1, 2 are only trivial base cases. Could it be negative 1, 0, 1? You know, so the beauty is with the factorial, we're just talking about positives. And the Fibonacci numbers sequences are talking about positives. So I didn't consider negative numbers in this at all. I just don't understand the rule. Let's just try. Let's just try some stuff. If it's less than 3, the problem is I don't see why it would be 0. Wouldn't it just be itself? Wait. Print 0. If it's less than 3, that doesn't seem right. I'm gonna be here, Fibonacci, in my sleep tonight if I sleep at all. Yeah, please definitely sleep. And I'm sorry. This is me since yesterday. This morning I woke up and I took a bath and I was laying in the bath. You know? First I was sitting in the shower and then I was like, okay, I'm just gonna lay down. And then I was just like in my mind thinking of Fibonacci sequences. It's like, it's trying to solve this thing. It's okay. Let's see. Meow annoyingly for hours. Meow, 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 meow. Don't tell me nonsense. Don't tell me nonsense. Let's see. Um, 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 mm, 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 mm. Meow. Meow, 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 meow. No, I stopped playing the game. I stopped playing the game. Mm-hmm. What are the variables that I need to take with me from one step to the next? The fib of 0, if we put it into here, the count is 0, so then it would give us 1 0 0, and it would just stop at 0. It would just give us 0. If we had 1 1 0 1, and then it would, what would happen then? The count is not equal to 0, so we would do inhibitor on it, and that would add A and B, so we would get 1 1, and then the count minus 1 becomes 0. And then we put that back in, and we get the count is 0, so it's 1. And then fib of 2 2 2 is not 0, so we keep going, and fibiter 1 0 2 would be 1 plus 0 is 1. B becomes A. And then 2 minus 1 is 1. And then that goes back in again. But 1 is not 0. So we go, instead of ending, we keep going. And the 1 plus 1 is 2. This becomes 2. And then B is still gonna be A from before, isn't it? And then minus 1, now it's 0. And then we go in one more time. For 2, 0, 1, well, we could just stop there. Because whenever the last number is 0, the answer is B, the middle number. So far, this is working out. Because we know that the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8. So then for Fibonacci number Fib 3, we start with 1 and 0, and then 3. But 3 is not 0. So we're going to go through the process. And it should repeat. Does it repeat? Let's see. Yeah, 1, 0, and then no. That's a lie. It's not 1, 0. It's 1, 1. 1, 1. And then 3 minus 1 is 2. And then 2 is also not 0. So it's going to go back into the distributor. And then 1 plus 1 is 2. And then this is 1. And this is 1. It goes down. And then it goes in again. This becomes 3. This becomes 2. This becomes 0. Because it's 0, the answer is 2. So then, yeah, we're doing something right. The third Fibonacci, the third Fibonacci number, is that the way to say it? The procedure, Fibonacci 3, should produce 2. Yeah. And then we can keep proving this. So Fib 4, 1, 0, 4. 4 is not 0. So we already know that you add A and B, 1. B becomes A. And you subtract 1. Add A and B. B becomes A. Subtract 1. Add A and B. B becomes A. Subtract 1. Add A and B. B becomes A. Subtract 1. And we get 3. The repeater will continue until morale improves. Is this recursion or hard-coded for loops? We're not doing loops. Hi, the baby swamp monster. I'm dying on the inside. I'm having fun. This is what we call fun. Anyway. Basically, Fibbiter is this. This is what this is doing. And this is a pattern, right? This is a pattern. And I don't know how to figure out the pattern for the other thing. Meow, meow, meow. I'm looking for the pattern. I need to find it. I'm looking for the relationship. I need to find it. I've never heard someone sound so much in pain while they say they're having fun. I don't know, it hurts in a good way. Anyway, it hurts in a nice way. We'll do one more. We'll do one more. Fib 4. We put 1 and 0 and then 4. That's a lot. That's a lie. We already did 4. This is 5. 5. And then 5 is not equal to 0, so add A and B, and then B becomes A, and then subtract 1. Add A and B becomes A, and subtract 1. Add A and B becomes A, subtract 1. Add A and B becomes A, subtract 1. Add A and B becomes A, subtract 1. Then you get 5. It checks out, right? 0, 1, 1, 2, 3, 5. 0, 1, 1, 2, 3, 5. So their thing does work. I just don't know how to I don't know how they figured this out, and I don't know how to go backwards and figure this out. It's like finding the relationship between the variables going up a step each time. We need a count. We need we definitely need n. I don't know if we count up or count down. That's another thing. I don't know if we count up from 0 or down from n. The base case is, oops. Let me look at this one more time. So in this, the base case was if count is 0, 0, even though there were 2. And then for this one, meow, 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 meow. If n is 1, 1. I don't understand I don't understand how to do this. I don't know, Francesca. I feel sorry for you guys though, because I'm really not asking you to solve it for me. I'm really not asking for that. I'm sorry if it seems like that, just because I'm stuck. I don't want you to solve it for me. I do want to figure out why it is what it is. So I'm not sure. Like, um, meow. This one, I want to know the answer. If you want to know the answer, didn't I pin it? Okay, I pinned it. You can look up the answer. So if you look up SICP exercise 111 solutions, people have entire web pages on it. But I don't want you to do that just to come spoil it for me. So if you're gonna do that, I'll be disappointed, to say the least. But if you're doing it out of your own curiosity so you can go to sleep, you can do that. Here's the question. Exercise 11. So, we have some function, and these functions they're recursive, so they can be written with a recursive process or an iterative process. I wrote the recursive process very easily, but I don't really understand how you break something down to write it as an iterative process, and I feel like I'm missing something, or yeah, I think I'm missing something because it doesn't feel like the book explains that very clearly. Um, and huh. Meow, 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 meow. Meow, 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 meow. Meow. That's all I have to say. Meow, meow, meow. Yeah, no, it's okay. You can go for it. Go for it. Go for it. Go for it. You know? It could be fun. It could be fun. Otherwise, bloop. Oh, savvy devil. I've been doing this on and off since yesterday, taking lots and lots of breaks. I will be taking another break, or not just a break. I will be putting this problem away, technically in 3 minutes, but I think I need a little bit more time. I think I want to work on it a little bit more today. And then, I will put it away. I'm gonna watch some videos again on, recursion and iteration and see if I can glean anything from it. Because I don't know how to approach turning or writing procedures that are iterative. I don't even know. Like, I copied the other ones from the book, but if someone told me to do it myself, I wouldn't know how, and that's what I'm struggling with. It's like, how does one come up with iterative solutions? Where do you obtain this magical knowledge? There's definitely something. I just don't see it. It feels like, it feels like I'm reading this and they're just making jumps and leaps that I don't know where the leaps and jumps are coming from. I'm thinking that Frankester and iClutz are on the right track with the idea that. So I think like the initialization being 1 and 0 is not arbitrary. So what you guys said I think is probably correct, that we need to initialize 3 instances or three variables because our function repeats 3 times. We have f of n minus 1, and then f of 2, f of n minus 2, and then 3. So I do think this is where the a, b, c comes from. Not through loops, but yes, through loops. But yes. Yes, through loops, but not without using the word loop, but yes, loops. And I don't understand how to write loops without writing loop. Because, like, that's the other thing. People are like, don't you just use a loop for that? And it's like, yep, yep. That's what loops are for. But, anyway, meow, 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 meow. Okay, so let's think about this. A scenario. What I was trying to see is that could we compare the two? So if we say that in the Fibonacci version, we choose 1 and 0 because of the condition, right? The conditions? Or is it not because of the conditions? Maybe it's actually because of the... It's because of this down here. Is it because of this? Because of the equation? We're adding A and B down here. And then, but why did they choose 1 and 0? I don't really know. That's what is kind of confusing me. When I say, what do you mean the 1 and 0? In the solution for the iterative version of the Fibonacci sequence, Fibiter, so for fib n, they said we initialize, like, it's actually in the text. And I didn't understand it. And I read it over and over again right here. It says, we can formulate the iterative process for computing Fibonacci numbers. The idea is to use a pair of integers, a and b, initialize to fib1 equals 1 and fib0 equals 0. So I guess that's what it means. It hasn't... But I don't know why. Like, I don't know why. Why? Whose idea is it to use a pair of numbers? Okay, they start with 1 and 0 because those are the first two numbers of the sequence. Thank you, live type. That's what I'm looking for. You need the first two to get the third number. Thank you, live type. This is the kind of... So you have to... Thank you! I want to hug you right now, unironically. Like, not in a parasocial way, but that's exactly what I've been trying to figure out, because I couldn't understand it, because they didn't write it in those words, and I think you understand the words better than I understand it. So, that makes a lot of sense to me. That makes so much sense to me, because yes, in calculating fib 2, you need, yeah, to get this one you need these two ones. Like, for every step you need the last two numbers. I don't know, for the problem that I'm working on, I couldn't exactly figure out. I'm still I think it's the same thing, but I think it's one more. I think it's like one more. Let me double check. I think it's one more. So yeah, I think you need 3 instead of the last 2. So like for f of 3, you need, because it's f of n minus 1, n minus 2, n minus 3, you need f of 2, f of 1, and f of 0. Oh, that answers so many questions for me. Thank you, though. Wait, thank you. So that's where they got those figures from. And then let me look at this one more time. Actually, I'll do it from here. Keep this here. Just a peep here. So tier 1. My next question was about like the order. So they don't write it as 0 1 n. It's 1 0 n, and then count 0. I don't know why. I don't really understand why. If count equals 0 b, my tummy hurts. But that makes sense because that's part of this whole thing. But does it always have to start there, or is that... I don't know. Because technically, the same thing is true for this. If, for our function, if n is 0, it is 0. My brain hurts. Maybe, Hi. You could see the pinned comment for what we're doing. I'm working on a problem, been working on it all day, and, since yesterday. Hope you guys are doing okay. Anyway, no, you know. So, like, hmm. So, in the Fibonacci case, you need f of 0 and f of 1, and then you add them to get f of fib of 0, fib of 1. You add them to get Fibonacci 2. And then for fib 3, you need fib of 2 and fib of 1, and you add them to get 3. For our function, it's similar but a little bit different. To get f of 3, you need f of 2, and then you need 2 times f of 1, and then you need 3 times f of 3. Okay, enjoy your walk. Okay, so let's think about this. If A is the previous step, and B is the step before that. Here, if A is the previous step, we do nothing to it, we just add it. So we're gonna add A. Wait, actually, I don't think this is right. Wait, let me think one more time. To get the final result of fib n, we need to add fib n minus 1 plus fib n minus 2. Okay. And A and B are essentially they should be the same thing. N minus 1, n minus 2, n minus 1, n minus 2. Meow, meow, meow. Meow, meow. So let me try something else. If we have f of 0, then we have, let's see, what is the one? Do we just initialize with 1? No, with 2, 1, 0, 0. Would that work? Meow, 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 meow. I think it's too many. I don't think it could be 3. How do we get 1? We don't just get 1. We have to go up a step. We have to transform it. So maybe this becomes 3, and this becomes 2, and this becomes 1. And this becomes 0. But I don't think that's the right way to, I don't think we should transform it arbitrarily. Okay, bye. Thank you. Meow, 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 meow. How do I write this as a rule? 3. Hi, hi, kitty cat. Hi. If the previous numbers are A and B, starting from 0. My tummy hurts. I need to go eat dinner and stop this, but let's see. Plus A. I don't know about flying, but we'll go places. We'll go places. Oh, I'm happy you're inspired. I hope it inspires you to yeah, to not shy away from a challenge. uh, yeah. Mhm. What would happen if we did this? Just try. Just think. In the case that count is 3, if we put 2103 in, 3 is not less than 3, then we get 2. 2 times 1, 3 times 0. That's not quite right. Because in the Fibonacci case, we need 3 numbers. This one, we need 4 numbers. But what would this give us anyway? It would give us +2, 2, and 0, which should give us 4. We are looking for 4 because that's the answer. The question is then what happens? Maybe it's like this? Wait, let me think about this. Maybe then maybe then B becomes A and C becomes B. I'm scared. Actually, I'll just type it. B. Add these. And then let B become A and C become B. Oh, I'm so scared. The following top level variables are reference but unbound. F iter in F. Wait 1 second. Let's see. I'm gonna put I think that's fine. I think that's actually fine. Let's try it. F of 0. I'm scared, boys. I'm so scared. I think we might have done it. I don't want to get too excited. Okay, F of 1 should be 1. F of 2, I'm gonna throw up, should be 2. F of, this is the real test. F of 3 should be 4. It's 2. Okay, this didn't work. It didn't work. It didn't work, but I feel like we're getting somewhere. Let me think. Let me think. I still got excited. Let's try another one. F of 5? Okay, so we're somewhere. What's happening? When I put in F of 3, F of 3 should give this. If it's less than 3n. I can't say close, but at least it's like one step closer. Okay, something is happening because it's giving me. It's just giving me A. Why is it giving me A? It does something. Wait, let's do another big number. F of 10. Okay, it just gives me 2. Hmm. um. Let's see. Let's see. Is it where? I'm wondering where it's getting 2 from. A. Plus 2ab plus 2b plus 3c. Meow 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 meow. Let's see, let's see. I should get 4 if I put 3 in here. I should get 4 and then 2, 1. And then 3. Okay, this is why. It's because of this count. I don't think I don't think we go down. Do we go up? Wait, or do we stay the same? Let me think. What would happen if we just stayed the same? Oops. Let's see. Okay, let's see. I made a mistake somewhere. Unexpected list terminator. Hi. Oh. I have too many parentheses. Okay, okay, okay. No errors so far. Wait. Wait. I'm scared. I'm so scared. Okay, we're gonna do f of 0, and we should get 0. F of 1, we get 1. F of 2, 2. This is where, this is where I don't know. F of 3. Ah, well, we didn't break anything. The computer is thinking. The computer is thinking, but at least we didn't get 2. I might have created an infinite loop. I might have created an infinite loop that doesn't resolve. So, um, let me go back. Let me go back to the drawing board again. Lesson 3, then we take 2 plus 2 times 0, which is 4. And then this becomes 2, this becomes 1. And this is 3. And then we put it in again. And that's not what we want to happen. We want, okay, I see. Hum, 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 hum. We want it to end, so how do we get it to terminate? How do we tell it that it's done? Maybe we go with B like the other one? Wait, not B. Maybe C? Oops. Let's try C. No, that's not right. Print or return. Let me think. Sorry, guys. Let me think for a second. If count is less than 3, print. Otherwise, I don't think we want this. I don't think we want this here. I think we want... See, I don't remember if I can do or, so... If... Like, can I... The function only returns if count gets updated to below a certain amount. No? The way I writ it, the way I've written it, no, the way I've written it, yes, you're right. That's a problem, right? So like, right now, yeah, right now it's only printing if the count is less than 3. Otherwise, it's just counting. So basically, what I'm struggling with is um maybe it has to be this. Maybe if it's 0. Let me think about this more. So like, let me think about this more. If count is 0, then we're gonna print C. Otherwise, we do this. But that's not enough. Well, oh yes, no, that's good because count is updating. Okay, let's try that. You're brilliant. Let's give that one a try. Let's give that a try. Oh, I'm so nervous. I feel like I'm gonna throw up. I'm so nervous. Okay, we didn't get an error. We didn't get an error, but let's see. Let's see if we get stuck in a loop again. Please work. Oh my god. Boys! Boys! We got a 4! Wait! We got a 4! Wait! If we get an 11, I might pee my pants. We got 11! Oh my god, we did it! Wait! I wanna hug you all. Thank you for being with me. We freaking did it! Wait! Okay, let's do another problem. Wait, f of, let's do 5. Let's just go ahead and do 5. Do we get 25? Oh my god, we did it. We fucking did it. We did it. It took 24 hours, but we figured it out. And it was thanks to you all. Thank you for being there with me and coaching me along the way and giving me just enough input to like aw. Yay, 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 yay. Okay, I think I understand it a little bit better now. Before, when we had it as like less than 3, it like it would get stuck. It would get stuck. I'm so happy. I'm so happy. I wanna cry. Let's try f of 8 and see if we get 335. F of 8. We get 335. I wanna cry. Wait. Let's save this work. Okay. Honestly, I don't want to overthink this. I'm just really happy because we didn't cheat and use like the internet to solve it. So I do want to see though. I do kind of want to see what other people's solutions are. We need a drink and a good dinner. I agree. I agree. Uh, exercise 1.11 solution. Let's see what other people have to say. I'll just use DuckDuckGo. Let's look at this one. Um. Oh wait. So they did use less than n. Ah, there's always more than. Wait, no. This is recursive. Okay, I got excited. Wait. Let me slow down. So the recursive. I forgot there was 2 parts to this problem. I was stuck on the second one. They used a loop, but we didn't learn loops yet. How did they use a loop? Okay, I guess it would have been easier to just use a loop, but hello? Hello? Hello, the book didn't I'm gonna find a different one. Let me find a different solution that doesn't use loops. They cheated! Yeah, they had extra information. Cause I know it can be solved with loops. Oh, here's one. Oh, this guy did it our way. Look. They did FIN ABC count. If count is 0, A. Huh. I think ours was C. How is theirs different? Oh, okay. They wrote it back. They wrote it not backwards. They just wrote it differently. So they wrote B, A becomes B becomes C, and C is the part that changes. Uh, like basically ours is flipped. They used A and we used C. But then they switched. Let me see. Meow, 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 meow. Let me see, let me see, let me see. I kind of want to test theirs, but I don't want to do it now. I might look at it tomorrow. And they use 0, 1, 2, and but they still counted down. Okay. It's not the same, but we ours works. I want to think about this more. And then I want to test this random person's maybe later. Let's see another one. I'm not satisfied yet. I want to see more. Whoa, this one looks interesting. Huh. This is so clean. Wait a minute. Can you just do that? Oh, but they're missing parts of it. They're missing the multiplication. You know what? I'm done now. I'm done now. I'm satisfied. We got it to work. I'm very, very satisfied. Let's just do f of 7 and see if we get 142. Yeah, we got 142. Okay, that means I can eat dinner. I can eat dinner and I don't have to starve because I'm stupid. Yeah, I think I've done enough for the day as well. We collectively have done enough for the day. It was a fun brain exercise. And tomorrow, yeah, this has been 7 hours so far. Technically, we have 3 hours to go. But there's a secret is that, like, I give myself permission to end the stream before 10 hours. Tomorrow we'll do exercise 1.2, and I think it's gonna be harder, but also maybe because we learned things. Oh gosh. Oh gosh, I'm not even gonna look at this until tomorrow. I'm blind. I can't read all of a sudden until tomorrow. Put that away. Yay, 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 yay. Oh, I'm so happy. I wish I started learning programming sooner. I didn't think it would give me so many, like, highs, like mental highs. Like, it makes me feel very happy. And, like, it makes me feel frustrated, but then elated when we solve something. It's so good. Oops. Oops. Okay. And then close all of those. Yay, I'm free! And they're all free as well. So, meow. Yeah, for those of you who haven't been here before, I'm Mrs. Moonson. I stream every day on Kick and Twitch. I do a podcast called Love Talk at 8 o'clock Universal, which is like 3 a.m. if you're on the East Coast of the United States. That's a different thing. I do that on Kick and Twitch every day. It's 30 minutes a day. and every day is like a different theme. But I'm a VTuber and I'm unemployable and I have a lot of student loan debt. And because of like the way the world is changing, the job market and AI, I realized that I don't think my degree will lead to like a fulfilling career. So instead, I want to take on entrepreneurship and I want to start my own set of businesses, but I have no skills. I'm very lacking. So right now I'm basically self-employed and working on like personal development and obtaining skills so that I can apply it to um business down the road. Just to give like a little background of what I'm doing here. So I have I don't want to say what my degrees are in, but I have a bachelor's degree and I almost finished a master's degree, but then I stopped. And um I wanted to go into medicine, but I don't think that's going to be an option for me. So but I'm excited about other paths and trying trying something else. Thank you, Scott. Yeah. Thank you for lurking and being here and even pitching in helping Frankester. You helped me yeah, you helped give me a eureka. um I'm in CS in uni. Oh, awesome. Very good. Very nice. Yeah. So I figure um one of the problems I have is that when I'm not streaming and I'm just like on my own, I tend to get distracted. I like scroll on Reddit all day or like watch YouTube videos. So I thought that if I could show up to stream as if it's like, showing up to a job and every day work on studying and bettering myself, I could do two things at once. I could take people on the journey with me. You could see as I learn and apply that knowledge to different things, but also I can keep myself accountable and stick to like a schedule. You're a hard worker. Think you can do whatever you want. Thank you, Kiss. You're so sweet. Yes, Kitty Pillar, it's been working very well. Like, I don't know why. When I'm by myself, it's so well, you could see, sort of like with the egg game, it's very easy for me to kind of get tunnel vision. So like I'll start playing and then I just won't stop myself. But at least now, because I have stream, I have people who are kind of like, okay, Kitty, what are you doing? You gotta get back to work, Kitty. So like, or at least there's like an internal pressure. Whereas when I'm by myself, I kind of just do whatever I want. So, but yeah, I feel really happy and excited and proud. Let's do more. Let's do more. Let's learn things. And even if AI comes around, even if they're super intelligent, I think it'll be still worthwhile for human beings to know how to do things, which is why I'm not just giving up. Okay, just because ChatGPT can code better than me doesn't mean I can't learn. I know how you feel. I got meds for that. Yeah. 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 Some people like if you have like ADHD or something, I have a lot in common with that stuff, like executive dysfunction, but streaming helps. Yeah. So now I'm gonna yeah, I will unstream early. And I'm gonna eat dinner and yeah, I'll prep for the Love Talk stream. I hope I see you guys again sometime. If not, that's okay too. I appreciate you. Thank you very much for being here, both to the YouTube side and the Odyssey side. Bye. Bye, bye, bye. Have a really good day if I don't see you. Bye. It gives me a schedule.